All right, so now let's look at equations with fractions and how do we deal with equations with fractions. Well, the first thing that I'll say is you always want to get rid of fractions when you come across fractions in equations. You want to get rid of fractions and then you can deal with the simpler equation. So how do we do that? First of all, we study the denominators. Here we have 2x over 3 minus 1 over 2 is equal to 1. The denominators we have are 3 and 2. So what we need to look for is the lowest common multiple of 3 and 2. That means what's a small number that 3 and 2 can go into, right? The smallest number that 3 and 2 can go into is 6. Other numbers can work, but you want to use the smallest number to make your working simpler. So if 3 and 2 can go into 6, right, I multiply the entire equation by 6. The entire equation by 6. So each of these terms is going to be multiplied by 6. So starting with the first one, this is 2x over 3 times 6. What I say is I first of all divide the denominator into 6. 3 into 6 gives me a 2. Then I multiply that 2 times the numerator. 2 times 2x gives you 4x. So I said 3 into 6, 2. 2 times 2x, 4x. Then here's my minus. 2 into 6 is 3. 3 times 1 gives me a 3 there. And then this one is no denominator, so it multiplies directly. 1 times 6 gives you a 6. So there you go. I've simplified this equation with fractions to an equation without fractions. So I take this 3 to the other side. I now have 4x is equal to 6 plus 3. 4x is equal to 9. Divide both sides by 4. My x is equal to 9 over 4, which becomes 2 1/4. Right. So that's it. Solve that equation with a fraction. Again, we have an equation that looks slightly more complex, but the approach is the same. We have 4x plus 1 over 5 minus x plus 3 over 3 is equal to 2. So what do? We'll look at the lowest common multiple of the denominators we have. We have 5 and 3. What's the smallest number that 5 and 3 can divide into? It's 15. So I multiply this whole thing by 15. So 5 into 15 will give you 3. Then 3 must multiply that entire numerator. So 3 times 4x plus 1. Then minus 3 into 15, that's 5. 5 must multiply this whole thing. So 5 times x plus 3. And then 2 times 15 gives you a 30. So there you go. The first step was to remove the denominators, and now I have a simpler equation without denominators. Then I can multiply throughout. Both of these will multiply by 3. 3 times 4, 12x. 3 times 1, that's a 3. Then minus 5. Minus 5. Both the minus and the 5 must multiply everything. So minus 5 times x gives you minus 5x. Minus 5 times 3 gives you minus 15. Some people make the mistake of not including the minus in the multiplication there. So this is equal to 30. So when I'm here, I collect like terms. Everything without x hops to that other side. So on this side, I'm left with 12x minus 5x. On the other side, now I have 30. Take 15 that side, it becomes a plus 15. And then a minus 3 because the signs are changing. So 12 minus 5 gives you 7x. If I add 30 plus 15, that's 45 minus 3, that's 42. Divide both sides by 7, I'll get my x is equal to 6. So that's it. That's how simple it is to solve that one. Let's move to the next example. Now we have 7 over 6 times 3y minus 1 minus 8 and a third is equal to 3 over 2, 2y minus 5. Oh, there's two things that we need to deal with here first. The first thing is you never want mixed fractions. Whenever you're doing calculations of any sort, you want to avoid these mixed fractions. So you want to turn this into an improper fraction. That's the first thing you want to do. And then the second thing is you want to have a better view of these fractions here, right? 7 over 6 times 3y minus 1 is the same as 7 times 3y minus 1 all over 6. So I can write it like this. 7 times 3y minus 1 all over 6. So all of it becomes over 6. And then I'm going to change this to an improper fraction. 3 times 8, 24 plus 1 becomes 25 over 3, right? Don't forget the denominator. And then here, 3 over 2 times 2y minus 5 is the same as 3 times 2y minus 5 all over 2. That's what it's like. So when it's here, we've simplified it just a little bit more to get a clearer picture of the whole thing. And now I look at my denominators. I have 6, 3, and 2. So what's the lowest common multiple of 6, 3, and 2? What's the number that 6, 3, and 2 can all go into? It's 6. So I multiply this entire equation by 6, right? 6 into 6 is 1. Then I say 1 times 7. I only multiply this thing on the outside. So 1 times 7 gives me 7. Then you get 3y minus 1. Don't multiply everything in there. Just multiply the one on the outside. Then minus 3 into 6, that's 2. 2 times 25, that's 50. This is equal to 2 into 6, that's 3. 3 times 3, that's 9. So I only multiply that 3 on the outside. Then when this 3, which has been multiplied to a 9, the 9 then multiplies what is there on the inside. Don't multiply the 3 on the outside and multiply the 3 on the in the 2 and the 5, because now you are over multiplying. You only multiply what's on the outside, and what's on the outside will multiply what's on the inside. It will carry forward that multiplication into the brackets. So now I can remove the brackets. 7 times 3, that's 21y minus 7 minus 50 is equal to 9 times 2, 18y. 9 times 5 minus 45. So we collect everything with y on one side, everything without y on the other side. So we can have our 21y, take 18 this side, it becomes a minus 18y. This is equal to minus 45 plus 50 plus 7. So 21 minus 18, that's going to give you a 3y, and this is equal to minus 45 plus 50, that's 5, 5 plus 7, that's going to give you 12. Then I divide both sides by 3, I get my y is equal to 4. So that's how simple it is. But the first thing is you need to take these initial steps and simplify the equation step by step.